Hi all, we have a new topic for this week. This is Unit 5 of the course. This is Intro to UX. UX is short for User Experience. It's not my strongest point, but we have some really good material to work with, and I'm sure we'll do fine. By the way, your main assignment for this week is to write up a paper with a wireframe, and I'll get into some details on that at the end. It's going to start with the 3 C's. These are in one of the assigned readings, Designing Multi-Device Experiences by Michael Levin. It's a really well-written book. It's well worth your time, although I realize there is a lot of book there to get through in 1 week. His concepts are based around these 3 C's, that we want our user experience to be consistent, to be continuous, and to be complementary, and we'll poke at each of these just a bit. Consistent. We all use multiple devices. We want the user experience to be similar regardless of the device. We want the user to pick the best device for the task and for their circumstances. Maybe they're at their desk or they're at home. Maybe they're on the road or camping or in a line, and this causes them to pick different devices. Content may need to be rearranged to fit different screen sizes, yet we still want things to remain consistent, and that becomes a bit tricky making that trade-off. Typically, if we have a larger screen, we're going to have more of a flat model where you can see everything at once, whereas if we have a small screen, such as on a cell phone, we have what's called a deep model. Maybe we don't always see all of our navigation. Maybe we have to float over the edge and it sort of pops out the navigation buttons or whatever. Maybe we rearrange things to be require some more scrolling. Whatever the case, we want as much as possible to tie back so that everything fits onto one model. So maybe we have to get the buttons to pop out for a small screen, but we want to label the buttons the same way so that when I press a button labeled something, it's going to take me to the same place, the same activity, or the same content that it would on a different screen. We may have different input devices. For instance, most PCs, we have a mouse. Most cell phones, we're going to use our finger. These work a little bit differently. A mouse is much more precise. We can have lots of small buttons, whereas a finger, we work better with larger buttons, right? So what do we do? Do we have small buttons? Do we have large buttons? Maybe we have an intermediate sized button, or maybe we're just very careful to label the buttons the same way and have sort of a similar appearance. Like if we use a color on one buttons on a PC to indicate some kind of action, we want to use the same colors on the cell phone, the same label, things like that. Another question here is called scaling. Does our model work well across different kinds of devices? Currently, we assume that we have somewhat similar devices, specifically that they have a screen is a very common assumption. That's true for PCs, for TVs, for tablets, for cell phones. We can talk about these things like flat versus deep. What about a very different kind of a device like an Alexa that has no screen? How is the user interface consistent between an Alexa and a PC? And I think the answer, the questions are still pretty open on that. We want to try to use the same terminology at a minimum, right? Maybe we need to revise some of that, because if we need a little different terminology because it's spoken, maybe we need to relabel buttons, something like that. It's hard to really know. Clearly, the problems of being consistent get a lot bigger when we have really different devices. Continuous. Continuous is the ability to move from one device to another device seamlessly. There are kind of two big areas here. We may be talking about a single task where we change devices in the middle of a task, or we may have different stages of a task that are better to do on different devices. So, for example, a single task, let's say we're out and about and we download a movie, we're watching it on our cell phone, we get home and we want to go to our TV. We don't want to spend a lot of time finding our place on the TV version. Oh yes, I was at minute 57. Let me fast forward for 3 minutes and try to stop in the right place. We want some simple way to simply say, yes, what I'm watching here, put it on the other device, right? Or a similar example, we're reading an ebook, maybe for this class, and we have the same place, we want the same place marked, whether we access it from a Kindle or a cell phone or a PC. And we'd rather not have to explicitly mark it, right? So I'm reading along, and for some reason or another, I'm interrupted. I go someplace, maybe something times out, or I close up my laptop or whatever, and then I come back to it, maybe on that device, maybe on a different device. I want to be able to pick up where I was last reading, without having a lot of hassle. I want to basically just reopen the book, have fall the same place. Maybe I have one book open and I decide to close it, and then a few minutes later I realize, oh yeah, now that I'm writing my paper, yeah, I need to look up that reference, and I want to open the book again, have it in the same place. Maybe I go back and forth between places in 2 or 3 different books. So we want to be able to pick up easily. Different example, different stages of a task. Maybe we research a purchase at home on our PC. Maybe we're going to buy a new printer or something. We research it at home. We build a list of items that we're interested in. Then we want to pull that list of items onto our cell phone while we're in the store. We don't want to take our PC with us to the store, even a laptop. But I do want to look at that. Maybe as I'm looking, I want to do price checks using my cell phone. I think Best Buy found that most people run price checks in the store on the items there. They look at the price on the shelf and they go check Amazon to see what the price is. But we don't want to have to start from scratch on our cell phone and say, show me all the printers or something. We'd like to build a list and then have that list easily available on the cell phone while we're elsewhere. So it's the same task, purchasing something, but it's different stages of the task, the research versus the purchase. We want to do one on our PC at home. We want to do the other on the cell phone in the store. We want the 2 devices to coordinate that way, which brings us to our next idea of complementary. This is definitely the newest. We want to use devices to complement one another. Each device has its own role in completing the task. For example, we might want to be able to use our smartphone as a TV remote, right? We don't want to watch the program on our smartphone. We want a big screen, but we don't want to have to fool with the interface to the TV because it's probably not very good. We want to take advantage of the better interface on the cell phone. Or another example, this is related to what we were doing, research on the PC, access on the cell. Maybe for something like trip information, we plan a trip in some detail, and then we want to save what we've decided onto the cell phone where we can access it easily on the road. Maybe the route we decide to go, or maybe our hotel reservation. We researched hotels and we did some Priceline bids and we got a room. I don't want to have to write all that information down. I want to just flip it to where it's easy to get at my reservation and so forth on my cell phone. We talked about product information when shopping as an example. Here's another example. Maybe we have a tablet that's providing a group board game while each user uses their cell phone to make their moves. This can be done with all kinds of games where what the entire group would see, the board, is displayed on a tablet laying up on a table. And then the view particular to the user and the controls and your actions might be on the cell phone or might be on a game controller, something like that. There's a new gaming hardware out that has this sort of idea that everyone has their own device and they interact with each other. Those are all examples. complementary things. So integrated design combines the 3 C's for a rich integrated experience. So when we do UX design, we should always consider all 3 C's. Consumers are becoming more demanding that their devices are fully utilized and that they coordinate with each other. Note that consumer may not have all the devices for a full experience, but should still get basic system usage up. Maybe we do our game on a tablet and cells, and so at a minimum you need a tablet and you need at least one cell phone for a solitary version. Maybe you need a cell for each player. Maybe you have a version of the game where if you have a second tablet, you can put them side by side and it gives you a bigger game board. Okay. There are videos on these 3 C's, and in particular, the one on complementary would be a good one to watch. I think that's a hard concept, at least for me, and I'm an old person, to think of all of the possibilities. I think that would be an area that a lot is going to emerge from. But it's a good book to read. The videos are pretty good, and particularly the video on complementary is worth watching. Moving on, this was not in the reading, but it's certainly a good source, and I would recommend it to you. It's called The 10 Usability Heuristics. They're by David Lazarus, and I've got a couple of references for you. On top here, we've got a YouTube video. It's not horribly long. It's about 10 minutes. Well worth watching. I would go for that. It's going to cover what I have here, plus probably a bit more, although I added some examples he doesn't have, but it's going to pretty much overlap. And then there's this same author, actually, this Nielsen. I'm not sure where David Lazarus fits in. Maybe he's doing the voiceover. But this Nielsen, who's a UX designer, has this article that you can read. It's a very pithy article. It's got a number of big links that have the main principles and a little paragraph. And then if you want to dig into a topic in more detail, there's a link. So I would have a look at that at this URL. So I'm going to walk through the 10 of them fairly quickly. We'll see what you think. Visibility of, so first one, visibility of system status. The system should always keep users informed about what is going on through appropriate feedback within reasonable time. His example, which I didn't think was that great, is a desk lamp. When you flick the on button, you can tell that it's on, right? When you flick it the other way, you can tell it's off. Now, that's sort of inherent in the design. Better one might be in my attic. I have a light switch to turn on the lights in my attic. Now, I might turn these on when I have the attic door closed, and then I don't see whether the lights are on or off. But this light switch is set up with a little LED right above the switch, which comes on if you've turned it on. So you can tell immediately is the light on or off without having to pull the stairs down and go up to the attic. We want to match between the system and the real world. The system you build should speak the user's language with words, phrases, and concepts familiar to the user. Rather than system-oriented terms, you want to follow real-world convention, making information appear in a natural and logical order. You want to think about who your user is and how they speak. His example in this one was children's books. They're written differently than college textbooks, right? They use color, they use different vocabulary. It's much shorter, punchier. It relates to things children are familiar with. That's pretty obvious. A more subtle one might be something like I've done insurance software. Insurance companies have a term called the effective date, the effective policy date. It has a very specific and a very important meaning. And if you put the concept, if you build the concept into a system, which you should, and you don't call it that, you don't name it that same way, your insurance people aren't going to know what you're talking about. So the effective policy date is the day it becomes effective. So suppose you get hired in a new job and they give you health insurance. Congratulations, that's great. When does it actually kick in so that if you get hit by a car, you can use your insurance? Typically, often, it's not the first day that you're there. A lot of policies, it kicks in after 10 days, or it kicks in during the first day of a full pay period, or something like that. It's not quite the same. Well, if you get hit by a car, it makes a whole lot of difference whether you got hit the day after the effective date or the day before the effective date. If you want to talk to an insurance person about that concept and you call it something else, they're going to be confused. And so if you're asking them to fill in, an insurance person to fill in some information on the screen about an insurance policy, and you use what makes sense to you and not what makes sense to them, it's not going to work well. User control and freedom. Users often choose system functions by mistake, and they need a clearly marked emergency exit to leave the unwanted state without having to go through an extended dialogue. You want to support undo and redo. You want consistent cancel and back buttons on each page. And back buttons are really good. You drill down a few levels and you realize you're in the wrong place. You don't really want to have to go back to the main menu in a lot of cases if it's something complicated. You just want to go back a step. It makes a huge difference in how usable it is. Consistency and standards. Users should not have to wonder whether different words, situations, or actions mean the same thing. And they say follow platform conventions. I'll talk about those in a second. As example, there are restroom signs. If we have male and female restrooms, and we can discuss whether that's a good idea or not, but let's assume for the moment that that's common. We want to be able to figure out which one is which. I'm sure you've been at places, usually they're restaurants, and they've gotten really clever about their signs to indicate male and female. Sometimes they get so clever that it takes you a while to figure out which sign means what. That's not really what you want in terms of a restroom sign, right? You really want to be clear what you're doing, right? Now, has it occurred to you, isn't there a conflict here between consistency between devices and your standards? And there may well be. These platform conventions, these are things like in Windows, in the upper right-hand corner, there's an X, and when you click the X, it kills the window, right? And there's a little underline thing near the upper right-hand corner on Windows, and that minimizes the window to the bottom of the screen, okay? And it works that way across all sorts of applications, yeah? On the other hand, on a Mac, you got those three little colored dots on the upper left. They look all 3D, and that's so clever and everything like that. And they do some of those same functions, but they're up on the left. Well, we just said that things should be consistent across our application devices. So what if we're using a Windows PC and we're also using an iPhone? Well, which convention do we use? Should it be different than everything else on the device, or should it be different than, or should it change when we change devices? Probably a little bit of both, but it requires some thought, and it's going to be really easy to make your user unhappy. Error prevention. Even better than good error messages, although let's face it, good error messages are a blessing, is a careful design which prevents the problem from occurring in the first place. Either eliminate error-prone conditions or check for them and present users with the confirmation option before they commit to the action. The author's example was a car dashboard, the warning lights, things like having the light that tells you that your engine is starting to overheat come on before while the car is still actually drivable. Now a lot of cars have a little thing that says your tire's underinflated, so you can go get air in it without it being an emergency where your tire doesn't exist anymore. Those are some good examples. Confirmation. A lot of things, when you exit them, they check to see if you've saved your work, and they ask you, do you want to save before exiting? Okay, that's really nice. Another one I've seen, Google Mail, Gmail. If you say something like, I'm attaching the file you wanted, and then you don't have an attachment, When you hit send, it'll warn you. It'll say, you said you were going to attach something in your message. You haven't. Should I send it anyhow? I find that to be very helpful. We can make this too complicated, but there are some things that, situations that come up often enough, it's worth doing. Recognition rather than recall. We want to minimize the user's memory load by making objects, actions, and options visible. The user should not have to remember information from one part of the dialogue to another. Instructions for use of the system should be visible or easily retrievable whenever appropriate. Example, the Google Smart Search. You start typing a search term and it tries to guess where you're going with it, and it does that based on your previous searches. There are some things that have different contexts, a classic one being a stolen base versus in baseball versus a stolen give, right? So if you start typing stolen, it might suggest, if you're a baseball fan, you've searched for stolen base before, it might give you a choice to just jump to stolen base. The other hand, you're a police officer, you work stolen cars, maybe it brings up stolen cars, stolen automobiles, something like that. At any rate, it's good rather than having to remember something for it to give you selections. You know, you've done these recently. Or another example, recent files. Sometimes I forget what I call a file. I could go searching for it, but if I know it was, say, a Word document, I might open Word and just look at recent documents. That's another example of recognition rather than having to try to remember what I was doing. Flexibility and efficiency of use. Accelerators unseen by the novice user may speed up the interaction for the expert user such that the system can cater to both inexperienced and experienced users. Allow users to tailor frequent actions. What is this talking about? Probably the best example is to have keyboard shortcuts in addition to menu items or palettes, right? A lot of programs, yes, there's a menu item to save, but a Control S will work as well. And you should try to use the ones people are already used to. There are a couple of applications that Control S doesn't do a normal save. Google Docs, for example. It's cool that it saves it continuously, and I don't actually have to save it. But it used to be if I forgot and I typed a Control S, it would go through this whole thing about, did I want to change the format and download and stuff. It was very annoying. I'm not sure if it still does that, or rather now it just ignores it because it knows it's saved. Another example, we may have a palette. Maybe we can customize that. We can drag our most frequently used choices onto the palette and it holds them there where they're easy to get to. Someone that's a novice user might not want to figure out how to do that. They aren't doing that much with it. They're doing basic stuff. But for an expert user, it might be nice to do that. And yet, by adding that feature to the palette that you can drag and drop new things into it, we don't make it harder for a novice to use. Aesthetic and minimalist design. Dialogue should not contain information which is irrelevant or rarely needed. Every extra unit of information in a dialogue competes with the relevant units of information and diminishes their relative visibility. So examples, Apple remotes are very nicely designed. The mouse, Apple designed a one-button mouse. Now, they didn't come up with the first mouse, although it was the first mass-produced. The most commonly used one before Apple had 3 buttons on it, and Steve Jobs says, I can't keep track of which of the 3 buttons I should use. This is too complicated. He decided that with one button, you never get the wrong button. That was maybe a good choice. Some reason Microsoft just had to go with 2 buttons, and I guess I'm used to it now. It's okay. The Google search page. Before Google, there were other people that ran web searches. Typically, their page to do that was very crowded and complex, had all sorts of stuff all over the screen. Google, they have the one nice simple box and a single button that says go search me, and if you hit the return key, it automatically does it. But if you're not used to the page and you don't know that you should hit the return key, there's a big old search button. Nice designs are often minimal. Less can be more. Help users recognize, diagnose, and recover from errors. Error messages should be expressed in plain language, no codes. Actually, I would disagree a little with that. Have the plain language, but also have a code, because searching for a long English sentence in Google, not as easy as searching for a code, right? If you want to see what someone else said about it or how they fixed it. But the plain language should precisely express the problem and suggest a solution. Certainly just having some error code that has no meaning to the user is not a good user experience. Help and document. Even though it's better if the system can be used without documentation, it may be necessary to provide help and documentation. Any such information should be easy to search, focused on the user task, list concrete steps to be carried out, and not be too large. Once again, the design of the Macintosh, one of Steve Jobs' big comments on that is, he said, people don't need a user manual to play video games. This was back when video games were a machine, like in an arcade, maybe Pac-Man. And, the instructions, they put the instructions on the front of the machine. It took maybe as much space as your hand. It was very obvious what to do. Computer programs in the same period often required thick user manuals. Some examples, though. IKEA assembly instructions. You buy a piece of IKEA furniture that you assemble. You can probably put it together without the instructions, but the instructions are there. They're easy to follow. They're very visual. Lego blocks. It's funny, when I was a kid, Legos weren't made for specific things. They came with a whole list of things you could do. They're very general. Now when you buy a Lego, the pieces are designed to assemble into something in particular. They have fabulous instructions. If you ever want to see good instructions, look at Lego's instructions. They're all visual. Doesn't matter what language you speak, you can follow them, right? Now, of course, you might be able to put together Legos, particularly the simpler ones, without the instructions, but it's good to have the instructions as well. Okay, so that brings us to the end of our 10 points, and you might want to watch the video on that. There are a couple of points that don't come up in the reading or the videos that I'd just like to mention. One is a big area of user experience these days is the idea of handling users that have disabilities. And in fact, many features in HTML5 were designed to make screen readers better at communicating the web to the blind. Blind people, when they surf the net, they have these things that will read the web page for them. It will verbalize the web page. It's very hard, particularly to produce navigation for it. HTML5, they added a lot of tags that make it clear what the structure of the page is, so the page reader can read those out to a blind person and they can figure out what they should do with it. In fact, a lot of cases, school websites, for example, if they have public funding, they're required to follow guidelines on how you do web pages for people with disabilities. And for a web page, disability is primarily dealing with the blind. Most deaf people can deal with most web pages okay. Another example, closed captioning of audio to make video accessible to the deaf. Maybe actually this video I'm making right now should really be captioned so that a deaf student could watch it. In fact, there was a case, University of California, Berkeley, was automatically putting all of their videos that they made. They would video all of the lectures all over Berkeley, and they would automatically load them all. They do a little automated cleanup, and then they'd load them all to a public server where anybody in the world could access and watch that lecture. They were sued by a deaf group that said, they should close caption them. And Berkeley said, we don't have any budget for that. And the court ruled against Berkeley and said, if you make it public, if you're a publicly funded institution like Berkeley, and you make it available to the public, you have to caption it or you're discriminating against deaf people. And they ordered Berkeley to caption it. And Berkeley said, since we don't have the budget, we'll just take all of them down, because the court simply said that the deaf had to be treated as well as everyone else. So by taking down all of the videos, no one got them. Not sure that's the best solution. That's what happened in that case. Now, Based on that, maybe this should be captioned, but I don't have a way to do it, so we won't. This has been kind of a negative comment here. There's more positive ones. This is a fabulous article. It's called Ability-Based Design. It's in the May 2018 Communications, the ACM. The ACM is one of the two large professional associations related to software. The Communications, the ACM, is their premier publication. It's a magazine. I checked, I think I checked, and I think it's in the library. You could get to this. See, this was written by a big group of people. Very fine article. Their point here is not to think of people in terms of, oh, they're disabled in this way, let's fix it. Their point is to say, you know, all of us have limitations, and we should make the software deal with that. So, for example, you might not think of yourself as being disabled, but perhaps you're carrying a small child up a stairway and you need to get the keys to your apartment out, and you have child's asleep and you don't want to put it down. At that point, you're not running a full ability getting those keys out, right? You could use some help. Okay. Ability-based design, they talk about a number of very specific examples that are kind of cool of making software adaptable, some of which have even gotten incorporated by Apple on the iPhone. So one of the things they came up with, a group came up with, was you can tell your cell phone, if you think about it as motion sensors, if you swing it around, the image changes, right? It goes from vertical to horizontal. It knows that because it knows how you're holding the device. You can tell from that whether the person's walking or not because it jars it a certain way. And you change it so that if someone's trying to use their cell phone while they're walking, you make the text bigger, even though it now it fits on the screen. You do things like that. And then when they stop and stand still, then you change the screen back, right? It adapts to people when they're walking. Another example, people, there are certain illnesses, one of them cerebral palsy, I'm going to forget the other one, but there are some illnesses where you retain precise control, but you tire very quickly. So for those people, having small buttons placed close together are easier to use. Then there are other people where their disability is such that they don't have good control over their finger to point, but they don't get tired. And for them, large buttons spread out are easier to use. So someone did a project where they asked you to work through a couple of quick sample pages, and it would see how you interacted with it, and then it would pick what the setting it thought was good for you and check and see if it was, and give some users a very different interface than others. It's something that is really only practical with software, and it's kind of neat that we're able to do things like that now. There's a whole branch of user experience that looks a lot at, spends a lot of time on ability-based design. It's a really very neat thing. Okay, the part you've probably been waiting for. Your assignment for this week, you're going to write a paper and you're going to draw a wireframe, and I was given an example, and so I'm going to walk through the example with you and hope it's helpful. The example I was given was for a prayer request system, so that people could make prayer requests to a group of people, to say a church, and the church would have a group of people that would pray for those requests. Some of the features of the system, describing it, I've pulled into bullet points. The system lets you submit prayer requests to a prayer team through a website. It allows submission of requests anytime with a degree of anonymity. The submitter has a choice of information they may leave to be contacted. Maybe they'd like a call back, in which case they can leave a phone number. Maybe they don't want to be called back, in which case they don't have to fill it in. This system, they're concerned about a bot filling the system with junk. So they've got one of those CAPTCHA things to check whether you're a bot or not. They think people need to feel attended and not ignored. They don't want someone that stumbles across, and you've seen those web pages where you're like, no one's paid any attention to this for years. That's not the impression they wanted to leave. So they're trying to find ways so that it would be apparent to a user that someone was actually paying attention to the system. It wasn't just a leftover. And so one of the things they did is they have a little section that has a daily inspirational verse. Since there's something new every day, it doesn't have a bunch of things on it. They're 10 years old. They think that will help them. The system will send email to a prayer team, and it sends an automatic response, such as an email to the user to let them know that they actually have submitted a request. You know, yes, you've done everything you need to do. We have your request. Now, for the assignment, you don't want a bullet point like I did on this slide. You want to turn these points into some prose and you want to fill it out a little bit more. But this is an example of the kind of system that they're looking for. Now, given that you've figured out some bullet points about what you want your system to do, what should you do next? Well, having written an overview and listed the major features of your application, we want to flesh it out with what you're learning this week in the course. So we want to use the 3 C's, and I would recommend for each of the 3 C's, you write a little paragraph that discusses your project in terms of the C. My project, to be consistent, is going to do this, this, and this. My project to be complementary is going to do this. My project to be continuous is going to do this. You're not going to have to build this whole thing. You're designing it, you're not building it. Don't worry about it, making it too involved. Okay? And then for each of the 10 usability heuristics, I would write a sentence or two on how it relates to your design. And if it really doesn't, if you just say that. Just say, for what I'm doing, I'm only writing this for the web. I'm not using other devices. It's not complementary. That's fine. But at least I know you've thought about it. And the same with the usability heuristics. Maybe it's as simple as saying, well, on all the screens, I put a cancel button like this in the same place. It could be that simple. But if you work through each of the 10, each of the 3 C's and then each of the 10 heuristics, you should easily put together a paper that meets the length requirement, which is 2 to 3 pages, not including the title page, and you have that information. Okay, well, this is lovely. This is lovely. I went to the trouble to get an example picture on this frame, and now it's not there. Okay, I'm going to post these slides as well. You'll have them in a announcement. I'll make sure that the wireframe is visible in what I post, and I'll let you do that. You'll see it doesn't have to be, the wireframe, don't freak over, it doesn't have to be real elaborate. It's a matter of drawing buttons and filling in prompts and drawing text boxes and making it fit. So don't get too freaked over that. Shouldn't be a big problem doing this week. So that's all for this week. I'm not going to show you any code or anything this week. I'll make sure that the wireframe picture gets in here by the time I post it. And we'll see you next week. Okay, come on. Asia. Okay. This is going to go into Purdue Okay.